Chapter 9, Common Core. Lots of scatter plots, lots of two-way tables. So let's get started. Which of these scatter plots shows a positive correlation? Okay, well, there you go. Ooh. Positive goes up and to the right like that. Negative goes down and to the right like that. This is a negative with an outlier, and that's a negative. So, pretty easy first page. Pretty easy first page. Okay, write a function rule for the table. Usually I do linreg, but I'm not going to do a calculator because I don't have one. So we're going to do this differently. We need to write an equation, and our equations are going to be in slope-intercept form. There's going to be a lot of moving parts for this problem, so I'm going to go slowly on this guy and stay with me. M is the slope. M usually means rise over run. So I would go to a graph and go up and over, but I don't have a graph. So I have to do rise over run using numbers and letters. So rise happens to be with the y values, and run is with the x values. Over here in my table, I don't have x's and y's, so I'm going to change the left side of the table into x and the right side into y's because that's usually what it is anyway. So I have to find my patterns here. How do we get from 2 to 4? Add 2, of course. How do we get from 4 to 6? Add 2, of course. And from 6 to 8? Add 2, of course. How do I get from 13.5 to 27? Add 3.5, of course. Add 13, and a half, of course. Add 13.5, of course. So my pattern on the x side, the hours, is add 2. The pattern on the y side, the pay, is add 13.5. So I'm going to write that over here. Okay, the y turns into 13.5, and the x turns into 2. Beep boop bop, bop boop beep, 6.75. Okay, so my slope is 6.75. What I have so far is y equals 6.75x plus b. Oh, what's b? I don't know what b is. B exists, and I did this in the previous chapter, when the x value is 0. Looking at my table here, I don't have a 0. So I'm going to be clever. Notice that as we move our way down, we add 2. How can we get from 2 to 0? Well, the opposite. Subtract 2. So if I were to subtract, do the opposite of add 2, I get to 0 here. Similarly, if I were to do the opposite of what we did over here, which was add 13.5 and subtract 13.5, I'd also get 0. So when x is 0, y also is 0. So b is 0. So putting it all together using that red equation at the very top, y equals mx plus b? Nah. 6.75x plus b? Nah. B is 0. So I'm not even going to put anything there. Uh-oh, I don't have y's, and I don't have x's. What I have is h's and p's. Oh, well, that's because the left side was originally hours. So instead of x, if I rewrite this equation on the bottom, instead of x, I should have h for hours, so 6.75h. And instead of y, I should have p for pay. And that takes us to this guy right there. Okay? Okay. Toughie. These problems are never fun. Linreg is always the easier way to go, but sometimes you just don't have linreg. All right. I'm not even going to look at the options. I'm just going to guess what we have. We have a positive correlation. What am I doing? The owner of an arcade measured the outside temperature each Saturday at noon and recorded the number of people in the arcade. The scatter plot shows the data collected. Which description fits the data in the scatter plot? Without looking at my options, it seems to me that as temperature gets higher, attendance gets higher. As temperature increases, attendance increases. So that's what's going on here. Positive correlation means as the one increases, the other increases. That's my trend. That's my line of best fit. So problem A. Option A. As temperature increases, more people come to the arcade. Yeah, but I'm very insecure. Don't know what for. I turn heads when I walk through the door. Let me check the others just to make sure. As temperature increases, fewer people come to the arcade. No. The number of people at the arcade is always the same. No. There is no relationship between temperature and the number of people at the arcade. No, that would be no correlation. So I was right. I was right. Problem 4. The scatter plot shows the number of students per class at Moneda Middle School and the number of magazine subscriptions each class sold for the fundraiser. About how many subscriptions did the class of 15 sell? Okay. Number of students, 15 is that dot right there. That dot seems to live right around 90-ish. So we'll go with 90. Okay. Okay. The scatter plot shows the number of CDs and disco that Disco CD Factory produced in different months. What is the best prediction for the month in which they produced 5,500 CDs? Here's my number of CDs. 5,500 would live right around here, but oh no, I don't have a dot there. So this is what I have to do. I have to make a line that best fits the dots that I already have. A line of best fit. So it looks like these dots are going in that direction. So that seems to intersect there, which happens to be in between the first J and the second J, which would be July. So a lot of people might say June, but since June wasn't the option, I'm going with July because it's closer. And plus, my blue line kind of dipped a little below, so maybe it should be more towards July anyway. But June's not even an option. July is an option, which means July is the logical answer. On to the two-way tables. 8th grade students were surveyed on whether they participate in playing sports outside of school. Complete the following table. Okay. Well, looks like I had 92 total males interviewed. So if 40 of them said no, then 92 minus 40 is 52. Okay. 90 girls were interviewed, females. And if 32 of them said no, that leaves 58 females who said yes. And just to make sure, 52 plus 58 is 110. How many females said yes? 58. How many males said yes? 52. Hello, familiar problem. It seems like we just did one just like you. 8th grade students, blah, blah, blah. What is the relative frequency of female students saying no? Relative frequency means your total. And in this case, what it wants is a percentage of female students saying no out of everybody. So the female students saying no is 32. Now you're going to be tempted to answer B, but 0.32 does not mean 32 students. 0.32 is supposed to represent a percentage out of 100. In this case, I want to do 32 out of my total, which is 182. Blink 182. What's 32 divided by 182?
That would be about 0.1758.
So 0.1758 is going to be 0.18. Okay. Kind of tricky problem. You randomly survey, no more multiple choice. You randomly survey students about attending a swim meet. You display the two categories of data in the two-way table. There it is. So we have whether they went to the swim meet or didn't, and you have if they're male or female. How many male students will not be attending the swim meet? Male not attending the swim meet, 25. How many female students will be attending the swim meet? Female students, yes, 52. Okay, so it's funny. The last problem was challenging. This problem was very easy. That's what you get when you have two-way tables. So here in problem 10, we are given a bunch of information. We are asked to graph that on this here scatter plot. Now, the scatter plot at all does not look pretty, just the way it translated into this computer thing that I'm doing. So I'm going to do the best that I can with what I have. All right, year one, 430. Year one, 430 is going to be somewhere around there. Okay. Year two, 320 is going to be year two, 320. So give or take right around there. Year three, 650. Year three, 650, maybe give or take right around there. Year four is 710. So 710 right around here, give or take. Year five, 1,170. So taking a jump, 1,170 is just a shade below 1,200. I could have done a better job with that one. And then 6 is 1840. Let's get a brand new color. Let's get a nice yellow. 6 is 1840. 6 is 1840. So we'll put it there. So I don't know. The graph here is not the best graph. I did the job though. And that's all that matters. All I had to do is just make a scatter plot. All right, okay. Describe the relationship between the data, identify any outliers, gaps, or clusters. So, describe the relationship usually means something along the lines of explain the correlation. What we have is we have a positive correlation. Positive correlation because it's going up, the data goes up and to the right. Here is a point that just doesn't seem to belong anywhere else. That's an outlier. One might argue that that little spot around the 10s and the 15s might be a cluster, but I'm not going to argue that because I don't think it is. Compared to the next picture where I definitely do have a cluster. And these dots are everywhere. So I'm going to say no correlation on this one. When the dots are everywhere and you honestly can't tell whether or not it's positive or negative, then you're just going to say no. Like I could tell on the problem up here that this is definitely a positive correlation. I can't tell. I don't care that there's that outlier just kind of screwing things up. It's definitely a strong positive correlation. There's nothing here telling me what it is. Now this is where we have to be careful. I see two possible answers here. I definitely see a cluster, and some might argue that that's a gap. But I don't know. Maybe we'll sneak it in there. It's definitely not an outlier because it goes along with the information. See, this information is going up and then down. So it's not like that dot down there doesn't seem to fit. The problem is, as far as correlation, is I don't have a linear correlation. And there's no such thing as positive and negative. So again, this is a no correlation. What I have is a non-linear correlation that's going up and then down, which means it's no correlation. Okay? Okay. Okay, the scatter plot shows the number of male teachers in a school district from 06 to 2012. So we got ourselves a little positive correlation going on right there. In what year did the school district have 41 male teachers? Let me see. 41 male teachers seems to be that guy right there, which matches up with an ugly looking 2008. The year Barack Obama was elected as president. How many male teachers did the district have in 2012? All right, well, let's go back up. 2012 is this guy, which seems to be a little bit more than 45. So I'm going to go with 47. You could be like, that looks more like a 48 to me. Well, It's an estimate. So I'm going with 47. Describe the relationship shown in the data. Well, it seems to me that this is a positive correlation, and as the years go on, more male teachers are hired. So that's how I'm going to describe it. Okay. As the years increase, as the years increase, so do the male teachers. All right. Let's hear it for the boys. Let's hear it for the boys. The men, the male teachers. You randomly survey students about their involvement in school sports and the school music program. The two-way table shows the results. So let's add this stuff up. Okay. We have music program, people that are involved is going to be 62 plus 34, which is 96. The people that are not involved in this program is going to be 41 plus 27, which is 68. Okay. People that are involved in sports are going to be 62 plus 41, which is 103. And the people that are not involved in sports, 34 plus 27, which is 61. Whether you add 103 plus 61 or you add 96 plus 68, either way, you are going to get 164. Okay. How many students are involved in the school music program but not school sports? So involved in school music program, involved in school music program. Oh, it won't let me do it. That's weird. That's very weird. All right, well, we'll just use a regular color. Um, Involved in the school music program. What did it say? Not in school sports. Not in school sports is going to be 34. What percent of students are involved in both? All right, so we have involved in both. So I have 62 out of a grand total of 164. What I have to do is divide 62 divided by 164. It's going to give me a decimal.
It's about 0.1951.
So I got 0.1951. In order to turn that decimal into a percent, I have to multiply it by 100, which means I just moved the decimal over twice. 19.51%. So about 1 in every 5 are involved in both. Look at these go-getting students. Proud of you kids. The scatter plot shows the total earnings, fare, and tips of a taxi driver during one day. So it looks like the more rides this person gives in a taxi or Uber, I forget the Vine where the kid says he never did an Uber driver. I'd never done Uber driver. That's funny. You guys know what I'm talking about. How many rides did the taxi driver give to earn $175? There's 175, matches up with that dot, which is 5. About how much did the taxi driver earn for giving 2 rides? Here's my 2. It seems to match up perfectly with about $100. And describe the relationship in the data. Well, it seems to me that the more rides given, the more money he makes. So the more rides given, the more money he or she makes. Okay. Makes sense to me. Dollars and cents. Okay, so what do we have? You randomly survey students in your class about whether they visited an amusement park in the summer. The results are shown below. So you have boys, girls visiting amusement park, boys, girls who didn't. Make a two-way table that includes the marginal frequencies. So the boys who did attend the amusement park's 38. The girls who did attend an amusement park is 29. The boys who didn't, 17. And the girls who didn't, I think that's 25. So we'll go with 25. 38 plus 17 is 55. 29 plus 25 for the girls here is 54. Now adding vertically, looking at the yes column, 38 plus 29 is going to be 67. And 17 plus 25 is going to be 42. Now, whether you add up 67 plus 42 or 55 plus 49, I'm going to get 109. For each gender, what percent of students visited an amusement park? For each gender. So I think this is how the what percent of students? Okay, so I think this is what it wants us to do. We had 38 for boys. We had 38 out of 109. Okay. That's how many boys visited an amusement park. This is going to give us a decimal. 38 divided by 109.
The answer is about 0.07339.
It didn't. 38 divided by 109. It only did 8.
I didn't get that.
38 divided by 109.
It's about 0.3486.
0.3486. Multiply that 100 by 100, and you get 34.86%. Okay? That's the boys. The girls who visited amusement park, girls, is going to be 29 out of 109. 29 divided by 109.
The answer is about 0.266.
0.266 times 100 is 26.6%. Okay. That's that for that page. The scatter plot below shows the relationship between the temperature outside and the average amount of sales at various winter clothing stores. So it seems to me, this data over here, the higher the temperature, the less sales that is made at a winter clothing store. Makes sense to me. Describe the relationship as positive, negative, or no, and also as linear or nonlinear. Well, this is a linear because it creates a line, not a perfect line, but it follows the behaviors as a line. And this is a negative correlation. So linear, negative. Given the relationship, explain the instance that would create a data point that does not follow the trend. So a relationship, explain an instance that would create a data point that does not follow the trend. All right, how about a sale? A sale. So maybe it's really hot outside and someone be like, everything is 50% off, and then all of a sudden you get 10 times more people. That might be like, oh no, it's really hot outside, but I don't know. I don't like that problem. But it's really hot outside, but all of a sudden we're making a whole lot of money. I don't know. So that's just an instance. As you can see, my creativity in the last 5 seconds just dipped. But that's all right. We're almost done the problem. Pack it. Scatterplot shows the total earnings, wages, and tips of a food server during one day. So very similar to the taxi problem that we dealt with a little bit ago. It seems to me as the person works more hours in a day, he makes more money. So about how many hours must the server work to earn $30? Looks like he has to... Now, okay, so this is where it gets weird. So after 2 hours, he doesn't make 30 yet. So during that second hour, it looks like he makes 30. So we're going to say it takes him 3 hours because if we're only going by like integer numbers, I don't want to be like, well, he could earn $30 in 2.5 hours. I don't like that. About how much did the server earn for 5 hours of work? 5 hours is that dot right there. So we're looking at about, I don't know, what is that, like $78? $78.
Make something.
I did. I made a scatter plot. And last but not least, describe the relationship shown by the data. Sound this word out for me, please, because you're so smart. What letter's that?
A P.
What letter's that?
O.
What letter's that? So that's sound it out.
Pawn.
Pawn. I'll take it. Positive. So as this person works more hours, they make more money. Does that make sense, hon?
Yeah.
She agrees. All right, that's it for the packet. Bye.